Let's begin. Today's July 28th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's go to turingmachine.info for the details. So in today's puzzle, we're using the following 5 criteria cards. Criteria card 2, 9, 14, 17, and 19. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 5 criteria cards, criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at our first digit, our triangle digit, and compares it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3, or should it be greater than 3? Criteria card B looks at our 3-digit solution and will let us know how many of those digits should be 3. Should there be no 3? Should there be a single 3? Perhaps 2? Maybe even all 3 should be 3. Criteria card C looks at our 3 digits, triangle, square, and circle, and the Turing Machine will let us know which one is the absolute smallest. So should triangle be the smallest? Should square be the smallest? Or should circle be the smallest? And then criteria card D again looks at our 3-digit solution, but this time will let us know how many evens there should be in our solution. Should there be no evens? A single even? Maybe 2? Perhaps all 3 should be even. Criteria card E looks at our first 2 digits, triangle and square. We'll add them up and compare that sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And remember, the objective of today's puzzle is to find that unique 3-digit solution that abides by all of the 5 criteria cards we just discussed. And the first thing we're going to do is we're going to test with an initial proposal of 314. So the first thing I'd like to figure out is the sum between triangle and square. So let's go ahead and test that. Okay, so the Turing Machine responds that it approves of my proposal. Notice that for triangle and square, I've got a 3 and a 1, and their sum is 4, which is less than 6. So the Turing Machine is telling me that the solution should have the sum of the first 2 digits, triangle and square, be less than 6. So let's go ahead and type that up in our notes in section E. So triangle plus square should be less than 6. Okay, so that does tell us something about what cannot be, and that is that neither triangle nor square can be 5, since if I add 5 to, say, at a minimum 1, that's already 6. So anything greater would be greater than 6, and we just can't allow that. So that means that, again, neither triangle nor square can be 5s, since if I add 5 to anything else, I will already get something 6 or greater. Okay, so for our next test, I'm looking at criteria card A, but I've already selected the single digit 3, and I normally don't like to test that. Well, let's go ahead and test criteria card C. Okay, so in this case, the Turing Machine also approves. Notice that among my digits 3, 1, 4, square does have the smallest value, so that means that the Turing Machine is letting me know that, yeah, square is the smallest digit. So let's go ahead and type that up in section C. Okay, so square is the smallest digit. Okay, so since square is the smallest, that means that neither triangle nor circle can be 1. Because if triangle were 1, what could be smaller than 1 if indeed square is supposed to be the smallest? So yeah, triangle can be 1 and neither can circle. Okay, let's see, what else? Could square be 4? So if square were 4 and it's the smallest, I don't think there'd be anything to pick for triangle, because 4 is definitely not smaller than 4. Circle would be okay, it could be 5. So yeah, I don't think square could be a 4. So let's go cross it out, and I think that's it. So yeah, if it's 3, obviously triangle could be 4, and circle could be 4 or 5. So there are options. Okay. So I guess next, yeah, let's go ahead and test criteria card. Still hesitant about A. I've got 1 even and 1 3. Well, if I test B and I get a check mark, it doesn't necessarily mean that triangle would be 3. But, okay. The other thing I kind of noticed is that I don't think there could be 3 evens, because if I had 3 evens, I know I would have no 3s, and that would make this card irrelevant. Criteria card B would be irrelevant if there were 3 evens. So we know we don't have 3 evens, but we still could have none, 1 or 2 evens. But I don't think the reverse is true. Not knowing how many 3s doesn't really dictate how many evens there could be, since you still have 1s and 5s. So, but I think again, you can't have 3 evens. That said, yeah, let's go ahead and test criteria card B to see how many 3s there are. Okay, so I do have only a single 3, and the Turing machine does not approve of that. So let's go ahead and type that up in our notes in section B, that there is not a single 3-digit. And again, what that means is that, and I guess similarly, okay, I guess maybe I was wrong. I think you can make the argument that there can't be 3 3s, because if you knew there were 3 3s, there'd be 0 even. So I think it's safe to say that there can't be 3 3s. I guess another reason is also there is a minimum. So that means not all of them could be the same digit. There wouldn't be a minimum if all the digits were the same. So I think there is not a single 3, and there's not, all of them can't be 3. So either there is a 3 or there's 2 3s. Well, okay. Well, that does it for this round. We did complete our 3 Turing tests. Now we're going into the phase where we'll be discussing a little bit more on how to construct a good second round proposal. So just because there is no single 3, it doesn't, I don't think there was anything to cross out. If there are 2 3s, obviously square couldn't be a 3 because it's supposed to be the smallest. So, and there really isn't talk about that there couldn't be a pair. I guess that's still plausible. And so the only possibility again is that either triangle and circle would both be 3, and then square would either be 2 or 1. And so I guess you could use the number of evens to distinguish. So let me go ahead and type that up. So I'm saying that 313 and 323 are possible solutions. And so there's 2 3s, and then either criteria card D will tell us that there are either 0 evens or a single even. And so I think that's the only cases where we have all 3s, or sorry, 2 3s. Yeah, okay. So that's 2 3s. What about no 3s? So if you can imagine this whole column just being crossed out, what would that leave us? We would have 1 even on top, either 2 or 4, and we'd be left with 1 and 2. And 4 2 is invalid because that sum would not be less than. So let's see, is it worth, well, I already started typing some stuff out. So that means it would have to be 4 1. And so if I wrote down 4 1 2, 4 1 3, 4 1 4, and 4 1 5, well, notice again here, besides criteria card C, we really don't mention circle at all. So that means it's being forced into that particular value, whatever that may be. So if I were to choose 4 1, oh, okay, never mind. I forgot, we're sort of imagining that there are no 3s. So that means I could have either 4 1 2 or 4 1 4. But I think that case would be ambiguous because I wouldn't know how to pick between 2 and 4. This is assuming that we do have 2 evens. They're both the case where triangle is bigger. There are no 3s. Square is the smallest. And say we had 2 evens, so 4, but for circle, what would it be? 2 or 4? There's just no picking it. So I don't think it would be 4 with 2 evens. It would be 4 1 5, because again we're imagining that there are no 3s. So 4 1 5. Okay. I think that's the only case with a 4. Okay, so and we already did the case where triangle is 3. What about 2? So that would force square to be 1. And then I think as well, 2 1 2 and 2 1 4 are ambiguous. How could you tell them apart? They're both triangles less than 3. There are no 3s. Square is the smallest. But then we could have two evens, 2, 1, 2, or 2, 1, 4. Of course, the sum is less than 6. You wouldn't be able to tell them apart. But 2, 1, 5, on the other hand, you could, because you would have two odds, 2, 1, 5, but no 3. So 2, 1, 5 seems to be the last possible. So either we have triangle B3. Ooh. Yeah, we've got two cases. I mean, we've got all the cases for triangle. So that's not good. What distinguishes them? So the last three all have two odds and one even, but not the first. Would it be possible for it just to be 3, 1, 3? Is that possible? That's 3, 2, 3. Okay, so, well, since I did pick, let's see, 3, 2, 3, let's go ahead and test criteria card D for the number of evens. Okay, so D. Okay, so the Turing Machine does approve of there being a single even. So that means that 3, 1, 3 is not possible. That's the only one that has all odds, or basically not a single even. So let's cross it out. Well, let's go ahead and test criteria card A. Okay, so triangle is not 3. Oh, and by the way, I forgot to write my notes for D, that there is a single even. So 1 even, 2 odds, but we just established that triangle cannot be 3, and that is quite unfortunate, because now I cannot, let me write it as triangle is less than 3 or greater than 3. It's unfortunate because the only thing that distinguishes these two solutions is triangle. Oh goodness. Okay. Yeah. Oh my goodness. I'm going to have to go to it. Okay. Well, let's go to a third round. And I'm pretty sure I lost this one. So which one is most likely? I don't know if it matters. I'll just say 2, 1, 2, 1, 5. And again, I'm going to test criteria card A. And that is wrong. So it was neither 3 or less than 3, so I had to be greater than 3. So let's go ahead and cross this out. And I guess there are no 3s. And I think that's it. So I think there's just too many things to cross out. So let me just go ahead and write out, oh, let me also cross out the 2, 1, 5 since that failed. So yeah, it would have to be 4, 1, 5. And yep, so based on this, triangle is greater than 3, yes. There are no 3s in this case, that's correct. The middle digit square is the smallest. There's only 1 even. The sum is less than 6, and that's it. So okay, let's go to turingmachine.info and verify our solution. 4, 1, 5. Okay, yep, okay, so that was correct, but I'm afraid that I did not do well. So let's see. First turn we did BCE, and then we only did 2 in the second round. So BCE, and then AD, B, and both C and E were correct. And the next round, I think A was incorrect, but D was correct. And in the third round, A was incorrect again. Amazing. Whoa. I am blown away. Wow. After that, well, wow. Yeah. Okay. I'm not sure what to say. I was almost certain, because we had 5 criteria cards. I had to go to a third round. I didn't even take advantage of the third test because it was A that I needed to test again. Okay. Well, I am totally stunned. Well, I'm trying to think of other deductions. I mean, I will say that, yeah, okay, I probably got very lucky on C to establish square to be the smallest, and to a certain extent, obviously, also getting E correct, having the sum be less than 6. Obviously, that did help us to, cross out some possibilities, but I didn't think it was that, well, again, yeah, I was lucky. Maybe I would have needed 2 more just to zero in on it. Well, yeah, 2 more. Well, that would do it, right? 6 plus 2 is 8. Okay, well, if you notice anything that you'd like to state, please share it in the comments. If you like the video, please give it a thumbs up. Otherwise, please do subscribe to be notified of the next video. Well, until next time, have a good one.